welcome to our last lesson in Chapter 2. Today we are going to try to accomplish two things. We're going to learn some information about angles, and as we do it, we'll also be practicing writing some proofs. So let's begin. Since the beginning of this course, really, we've been using a relationship that exists for all pairs of vertical angles, that they are equal in size. Today we're going to prove that for the first time using deductive reasoning. So you can see that I have a drawing that shows two lines intersecting, and I've labeled the angles there so that I can talk about them by name. And what we are going to do is prove the vertical angle theorem, which says vertical angles are congruent. If we were going to write this in if-then form, it would say if a pair of angles are vertical angles, then they are congruent. That is, what we are given is information about angles that are vertical. Now I'm going to focus in on a specific pair. I'm going to say that angle 1 and angle 3 are vertical. What I want to prove then is that angle 1 is congruent to angle 3. If I can do that for this pair of vertical angles, then I can say it's true for any pair of vertical angles. Since we don't have anything here about angle size, this is generic, we'll be proving it for all time. Today I'm going to ask you to think with me as we begin each logical argument. We want to be thinking about a plan. And this one, we're going to use information about linear pairs. And you'll remember that angles 1 and 2 form a linear pair because they're outside edges, they're adjacent angles, and their outside edges form a line. That same thing is true about angles 2 and 3. If you look at this picture from that perspective, that also is a linear pair. And we know that all linear pairs measure 180 degrees. We should be able to use subtraction to show that angles 1 and 3 are congruent, since we know that if we take away angle 2 from the linear pair here, that leaves angle 1. If we take away that same angle 2 here from the linear pair, that leaves angle 3. They must be equal to each other. Let's see if we can't flesh that out a little bit, and we'll start our proof writing the way that we almost always do. That is by listing the given information. Angles 1 and 3 are vertical. That was given, and you'll recall, I hope, that the things that we can use as reasons in proofs is that piece of information, given information. We can use properties. We can use definitions. And we can use postulates and theorems. And we have not had a theorem yet. This will be our first one. Okay, angles 1 and 3 are vertical. Now, as far as planning goes, and I'm going to just go back to the diagram, since they're linear pairs, the measure of angle 1 plus the measure of angle 2 has to equal 180. That is, by the way, the definition of a linear pair. And that is also true about the measure of angle 2 plus the measure of angle 3. I'm not going to write the reason again, it's the same thing. What I do have now, though, are two things that both equal 180 degrees. So since this measure of angle 2 plus measure of angle 3 is the same as 180, I'm going to substitute. And I'm going to write this statement instead. The measure of angle 1 plus the measure of angle 2 is equal to, and now we're substituting. Instead of that 180, we're going to write this. Measure of angle 2 plus measure of angle 3. I like that. And I also see that I have a measure of angle 2 on both sides. If I subtracted that away, so I'm going to apply the subtraction property, I would be left with this. the measure of angle 1 equals the measure of angle 3, and that's very close to what we have to get to. We have to be congruent. I am going to write a note out here just in case we forget. We subtracted measure of angle 2 from both sides. Now you don't have to write that for me, but I'm writing that for your information. We can jump right from here to stating that those two angles are congruent. And the reason we can make that jump is that the definition of congruent angles, or definition of congruent, goes from equal in size to congruent. So when you see the jump from equal size to a congruent mark, you've applied the definition of congruence. You know, a statement that can be proven deductively is a theorem, and you folks have just proven your first geometric theorem that vertical angles are always congruent. Good work. Okay, I wanted to remind you that not only have we proven it, but now we know that we can use it. So I'd like us to just take a second and solve this little algebra problem that arises from this diagram. If you pause the video, that would be wonderful. Very good. Here is my solution to this. Vertical angles must be equal. That's what the theorem says. So I wrote an equation that says that expression 6x plus 16 is equal to 136. I subtracted 16 from both sides and divided by 6 to come up with x of 20. And that is familiar work to all of us. The next theorem that I would like us to look at is called the congruent supplements theorem. And this is, the language is a little bit weird, but I want to see if I can explain it to you. If two angles are supplements of the same angle, that is, if this angle is supplementary to this one, angle 2 is supplementary to angle 1, and angle 3 is also supplementary to angle 1. So if two angles are supplements of the same angle, then those two angles must be congruent. Folks, this is also a geometric theorem that can be proved using algebraic methods. In fact, it'll work out, I think, very similarly to the problem that, or to the proof that we just wrote a moment ago. What I'd like to have us do, we already have given information, okay? I know one thing for sure. We're going to have to know what it means to be supplementary, so I'm going to ask you to think about that while I'm setting up my T-chart. Statements on the left, reasons on the right. As we work through this, we want to be able to go from supplementary angles to congruent angles. So the first piece of information that we have is angle 1 is supplementary to angle 2, and that angle 1 is supplementary to angle 3. Now, I asked you to think about what supplementary means, and that's because we need to know that. We're going to use the definition of supplementary angles here. They add up to 180. So the measure of angle 1 plus the measure of angle 2 is equal to 180. It's also true that the measure of angle 1 plus the measure of angle 3 is equal to 180. That is all the definition of supplementary. Now I see this is where it starts looking like the previous one. So to remember what we did next, we have two things that are equal to 180. We're going to substitute. We're going to say, okay, if they both equal 180, then they got to equal each other. So the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 1 plus the measure of angle 3. And just like in our previous proof, we've got an angle whose measure is on both sides of an equation. We're going to subtract, and what we're subtracting is the measure of angle 1. That's going to leave us with the measure of angle 2 equaling the measure of angle 3. Again, that's very close to what we have to get. We have equal, we need congruent. So we're going to apply the definition of congruence and say that angle 2 must be congruent to angle 3. Very similar to the last proof we had. Our next result we are not going to prove in our notes here. However, You will prove it in the homework. I want us to know the theorem in the same way that two angles supplementary to the same angle are congruent. This theorem says two angles complementary to the same angle are congruent. And I would ask you to think before we get away from just this, what does it mean to be complementary? Supplementary was 180. Complementary, that means we add to 90. Now this one, again, we're not going to prove it here in our notes, but you will see it in your homework. So it'll be very similar to the one that we just looked at. We have two more theorems to talk through quickly today, and these are both about right angles. The first one, theorem 2-4, is very straightforward and will make total sense to you. If two angles are right angles, then they must be congruent. And I've done a little bit of editing on my conditional. If two angles are right angles, they are congruent. What we're given here, and you can see it in our picture, is that angle 1 and angle 2 are right angles. Our job is to prove that they are congruent, and you see we already have some of our information in place. The plan, I think, would be to look at the definition, apply the definition of right angles. In fact, as you're writing this, I hope you're thinking, well, yeah, it's that they measure 90 degrees. Then we're going to have two angles that both have the same measure. That means they are congruent. This is going to be a very, very straightforward little proof here. What we start with is what we're given. Angle 1 and angle 2 are right angles. And that was the given information. We said that we want to apply the definition of right angles, and this is the place for it. Definition of right angles. That means if you're a right angle, you measure 90 degrees. So angle 1 measures that, as does angle 2. The third step of this, you got this two things that are equal to the same thing. They must be equal to each other. Whoever wrote this slide wrote transitive. I would prefer substitution, but I will tell you that our textbook kind of uses those interchangeably. I think substitution is better here. However, transitive is also appropriate. But what we're saying is, if they both measure 90, then they have to equal each other. The measure of angle 1 is equal to the measure of angle 2. Substitution. Then we jump from equals to congruent, and by now we realize that that's applying the definition of congruence. Good job. Any right angle, or all right angles, are congruent is a way to think about this. Theorem 2-4, all right angles are congruent. And our last result of the day, one more about right angles. Let's read the statement of this theorem. If two angles are congruent and supplementary, then each is a right angle. Two angles congruent and supplementary. Same size and add to 180. Then each must be a right angle. Well, if you start even thinking about a drawing of this, you will see that that has to be right. We have two congruent angles. I'm going to draw it this way, although this is not the only way that I could draw this thing. This angle and this are congruent, and together they add to 180 or are supplementary. Okay? You can see that the only possible measure for those angles has to be 90. Our job is to put that in proof form. I'll be your partner. Okay? Let's determine what we're given here. Two angles. We should probably give them a name. I'm going to call this one angle 1 and this one angle 2. They are congruent and they add up to 180. What we're supposed to prove is that they must be right angles. So let's jot down the given information. We're given angle 1 is congruent to angle 2 and angle 1 is supplementary to angle 2. That's our given information. What we have to prove, angle 1 and angle 2 are right angles. All right, let's see. We could write this in 2-column format. However, we could also, that's not the only form for writing a proof. We could also write a little paragraph, and I think I'm going to prefer the paragraph here. So in a paragraph proof, we have to state the same things basically that we would in 2 columns. It's just that we put words around them. So given that angle 1 is congruent to angle 2 and that they are supplementary, we know, and I'm going to put in parentheses, by definition, we're going to apply definitions for congruence and for supplementary, that the measure of angle 1 is equal to the measure of angle 2, and that the measure of angle 1 plus the measure of angle 2 is equal to 180. The next logical step would be substituting, and I'm going to write that property's name here. Substituting gives, and what I'm going to do is replace this angle 2 right here, that measure of angle 2, with an angle 1, because we know that they're the same. Measure of angle 1 plus measure of angle 1 is equal to 180. Or, and we're going to just do a little arithmetic here, 2 or twice the measure of angle 1's equal 180. Do you see what we did there? Measure of angle 1 plus measure of angle 1 is 180. That can be rewritten by saying twice the measure of angle 1. Dividing, we see that the measure of angle 1 is equal to, so dividing by 2, measure of angle 1 is equal to 90. Okay? Period. Substituting, again, because we know 1 and 2 are the same, substitution tells us that the measure of angle 2 is also 90. Okay? Therefore, again, by definition, because this is a definition of right angles, angles 1 and 2 are right angles. I want to read through that proof again and just make sure my logic makes sense. Because that's where we had to get that they're right angles, and I think we did. Given that angle 1 is congruent to angle 2 and that they're supplementary, we know by the definitions of those two things, congruence and supplementary, that angle 1 is equal in measure to angle 2, and when we add them together we get 180. Substituting, or using the substitution property, would give us this, that the measure of angle 1 plus itself is 180, or twice the measure of angle 1 is 180. Dividing by 2 tells us that the measure of angle 1 must be 90. Again, substitution, since 1 and 2 have the same measure, angle 2 is also 90. Therefore, because right angles have 90 degrees, angles 1 and 2 must be right angles. Ladies and gentlemen, not everyone enjoys the paragraph proof. Okay, I happen to like it. I use both. The 2-column proof is a good learning tool, but the paragraph proof is really just, it's a mental flow. You write down what you're thinking, and for some folks that is a little bit nicer than the whole 2-column format. We've seen both, and when we talk about this tomorrow, you'll be welcome to use either style in proofs that you write. All right, I need you to get out there and do that. You try. We'll see you in school.